language, the ability to produce words. So we evaluated 31 people with autism who came into the clinic without communicative speech on these measures, and we found a peculiar pattern in a third of them, who are in pink here, of slightly impaired gross and fine motor skills, very, very much impaired oral motor skills. Oral motor skills, the ability to move the mouth and the vocal tract. Very much impaired receptive language, expressive language, and receptive language that is preserved out of all proportion to the impairment in expressive language. So in other words, these people can listen, they just can't speak. So the straightforward conclusion from these data is that in this fully 1/3 of people with autism who lack communicative speech, probably the reason they're not speaking is that they can't move their mouths to speak and their vocal tracts to speak. So if we could give them an alternative way of communicating, maybe through movement of the hand, then we might somehow unlock communicative ability. So this work is coming out of my relationship with my collaborators in India. I mentioned the Kamdil Clinic in Bangalore. I would say in general that Indian and South Asian in general therapeutic practice for autism recognizes the relationship between motor skills and cognitive skills in a much, much greater way than we are used to here in the UK and Europe. And we do have a lot to learn from that sensibility. This software is one aspect of it. Some descriptions of that relationship. Dr. Vasudha Prakash, who runs the VXL Educational Trust in Chennai, has talked about thoughts housed in bodies and minds that may be fragmented, which is a lovely description that jibes very, very well with our own physiological studies of autism, which describe lack of integration of separate cognitive and motor skills. Dr. Pratibha Karant, my collaborator at Kamdil, talks about building up communication from what she describes as prerequisite skills. Things like gross and fine motor skills, abilities like pointing, activities of daily living that require abilities of sequencing and executive function, and of course, joint attention, both responding to and initiating requests for joint attention. A lot of therapeutic methods, though very well intentioned, tend to work against rather than with an autistic cognitive style. That is, we ask people with autism to do things in a way that they can't or can't easily or just don't like to do them. And people talk about autism as a problem with perspective taking. In fact, there's a great problem in taking the perspective of the person with autism amongst researchers and to a lesser extent, some therapists. So this child, if you look at him, he may seem to be just purposelessly shaking a string. In fact, if we had a movie of this, what we would discover he's doing is he has discovered a parametric relationship between the angle through which he deflects his wrist and the arc that the string makes. And he's doing this over and over and over again and testing out the parameter. In short, he's behaving as a little scientist. He's trying to learn something. Nobody has told him to do this. He's doing it on his own. This kind of thing is a teachable moment, and usually it's missed by those of us who are much, much more concerned with conventional social behavior. So we've done a lot to adapt the typical tablet, in this case iPad interface, for what we know about an autistic style of motor interaction with a computer or motor interaction with the world in general. One very important point about the way people with autism, especially severe autism, interact with the physical world is that they tend to use what we call an open loop style of motor control. This is very, very pronounced, especially in those people with severe autism and severe motor control problems. So there is a failure to integrate ongoing visual and proprioceptive feedback with a movement that is in progress. That is, if I try to reach to a target with my arm, if I try to pick up this cup, for instance, I use two inputs: proprioceptive sense of where my arm is in space, and visual sense of where my arm and my hand are in relation to the cup, to automatically adjust my movement. And so small errors develop in my movement as it goes on. I automatically, without thinking about it, correct those and grasp the cup. If you can't do that, or you can't easily do that, then your efforts to interact with the outside world are always going to be kind of like playing a game of pin the tail on the donkey. You're not using visual input, you're not using visual feedback, you're not using proprioceptive feedback, you're just sort of gesturing almost quite literally blindly. And this is one reason we think that a lot of people with autism will tend to glance at a stimulus, then glance away, because that visual input is not useful to them, and then make a movement towards it. Well, what does this mean for interaction with a touch screen? If they're going towards a target, they're probably going to hit somewhere near the target, but probably right not on it if it's a small target. What we see in a lot of people with autism is that they'll correct for this by then wiggling the finger around whilst it's in contact with the glass and successively approximating to the correct position. Then by the time they release contact, their finger will be where they want it to be. Well, the trouble with that is that most computers are built to recognize where you first touch the glass, right? Not where you leave the glass. If we just reverse that, we find that the interaction runs a whole lot better. So we record where they leave the glass rather than where they touch it. There is an issue of repetitive behaviors in autism. Computers are very, very predictable things, and of course if they play a predictable error tone or something in response to a wrong input, that error tone might feel so rewarding to the individual autistic user that they'll make that error on purpose again and again and again just to hear the error tone. So we want to get them out of that rut, so our software incorporates features for loop detection, where if the software discovers itself doing the same thing, issuing the same stimulus over and over and over again, it will shut down that loop and get out of it. Lastly, the most important point, this is not software that acts on its own. The caregiver is a very, very important and a crucial part of the therapy. It is that person who models the interaction with the software and who directs the person with autism in an errorless learning format. Without the caregiver, this software is totally, totally useless. So we want this to be not an experience of autistic user and the tablet computer, but rather an experience between the autistic user and the caregiver or therapist with the tablet computer. Okay, before I start the video, so cue that up, but before I start it, the software contains three modes, which we call point mode, type mode, and speak mode. I'll show you point mode first, and if point mode were the only thing we were doing, it's basically a glorified jigsaw puzzle. What we're trying to do is teach people with autism just how to move their fingers to interact with a tablet computer. That's it. We do that through what tends to be a very motivating framework for people with autism, that of a jigsaw puzzle. So let's go with the video.
Let's fix it here. Bring this piece. Allow me. Bring this piece here.
So you see the direction, the modeling, and you will see the errorless learning going on. It's just a minute long.
Yes, next piece, next piece. Try again. Let's finish it, come on.
This is a complex puzzle, and the user here is getting kind of frustrated. So the caregiver knows just when to intervene. And there we go.
Which one next? Very good. Next. Very good. Bring it here. Very good.
So I hope you're seeing even within this brief trial, there is something of a learning effect. On the whole, although there are lapses, the student is getting much better at it. Okay. So that's point mode. As I said, really nothing more than a glorified jigsaw puzzle, but it serves as an introduction to the software. And then after a long period of experience with point mode, we move into type mode. Let's run that video. Okay, the difference here is we're moving from iconic to symbolic representations. So now, instead of pointing at the piece to cause it to pop into place, you have to point at the key that the piece is labeled with. So she's modeling that behavior. And when the person with autism first has to do it by themselves, it really throws them initially. And they will persist and perseverate with an iconic style. There we go. He's going for the iconic piece rather than the corresponding symbol. And again, errorless learning.
L. You have to finish typing. L. O. O. Good. O. Where's O? Where's O? Good. N. Yippee! Balloon. Now let's try next one. Which one do you want?
So we contrast that one to the next one. You'll see a little difference creeping in.
Chocolate is long. Let's try book. Let's try book. Right. Waiting. Waiting. Alright. B.
So now he's got it. He's going right for the letters. You can see there's some motor targeting error.
Let's try another one.
But he's getting them.
Waiting. Waiting. E.
Every now and then he gets frustrated and goes back towards the iconic representation.
E. Yay! Very good. Let's try one more. Let's try one more.
Okay. So I hope that's enough to show you what those two modes are all about. We also have a mode called speak mode, which we don't expect many people who are the target users of this to be progressing to, but we wanted to include it for those who can. Speak mode integrates the open source Open Ears speech recognition system. And what we do is we model a word syllable by syllable. In order to cause the piece to pop into place, you have to speak the appropriate syllable. So we go from object as sequence of puzzle pieces to object as sequence of graphemes to object as sequence of syllables. So we have just started a feasibility study, which we hope is going to lead to a full randomized controlled trial of point outwards. And I wanted to share with you the elements of this feasibility study. I'd be very interested in your feedback as to what you think is going to work or what you think we should add or subtract. So we're going to do up to 120 users. This is in cooperation with NHS Peterborough Neurodevelopmental Center. For 8 weeks of exposure to the software, and our parent focus group suggested that a target of about 5 hours of exposure per week would be reasonable. We'll see if they hit that or if it's ending up going to be a little less. We split those people into treatment and control groups matched for chronological age and for Vineland developmental level. And we split those using our previously computed discriminant between the motor intact and the motor impaired autistic subgroups. We split them into those two, and we assay the effect of the software on those two separately. Internal measures to the software logs all stimuli presented and all interactions, and it phones home and uploads everything that it's done, of course with users' opt-in consent. So we have measures of visuomotor targeting error, we have measures of touch force from the internal accelerometer, and we also have a measure of anticipatory movements of the iPad. If the caregiver is moving the iPad to cue the correct letter, then we know that they're doing that. External measures are, of course, also important for validation of any result. So our test-retest measures are going to comprise Mullen scales of early learning, the clinical evaluation of language fundamentals, and of course, given the population, we're going to be much more interested in the receptive than the expressive measures there. The verbal motor production assessment for children, for the people who do progress to speak mode, we're going to be assaying their ability to move the mouth and the vocal tract. Social responsiveness scale 2 and parenting stress index 4 to assay the effect of the software both on the child and on the family. Vineland adaptive behavior scales as a general developmental measure. And lastly, we're going to be collecting qualitative data on usability of the software, acceptability of the software to families, and their fidelity to the recommended treatment schedule. So to wind up, and I hope this has been about 15 minutes, I want to thank the schools that we've piloted with, both Communication Deal in Bangalore, with whom we've done a lot of work, and also 2 schools local here to Nottingham, with which we did some pilot work just this past summer, Rose Hill and Oakfield. Other than that, this work was funded by a sort of agglomeration of grants. My early career award from the U.S. National Science Foundation started the work. It was continued with a Fulbright Nehru Research Fellowship, and Nottingham Trent University Health and Wellbeing Fund just gave us $20K to complete some pilot work over the summer. If you would like to know more about this software, please go to www.autismcollaborative.org/pointoutwards. And I gather these slides will be up on the website so you can get that down. This is not yet up on the App Store. We're doing a final round of bug fixes quite literally this week. It will be submitted soon, and it will be free to download. It is released under the Mozilla public license, so you can have the source code. In fact, you're encouraged to have the source code. Thank you very much. I'll take any questions.
Any questions?
Yeah.
Hi, Matthew. Thanks for that. That was really interesting. So I might miss this, but have you decided on a control condition?
Yeah, I didn't have time to throw the control condition in there. So, very good question. What's the control condition when we were evaluating this software? We decided that as a first cut, as in the context of the feasibility study, we were going to control for exposure to the iPad. We're going to control for time in front of the screen. And what we're going to use is a selection of educational iPad apps that have been identified by Autism Speaks. We don't want to settle on one particular app because different strokes for different folks, different families might be into different iPad functions. The important thing to control for is just time with the iPad. So that's what we're going to do. I should also mention the control group is going to be offered the Point Outward software after the end of the 8-week control period.
Any more questions? Laurie?
I was very interested in what you said about errorless learning. Because you often think of learning the other way, you learn through your mistakes.
Yeah.
So is there a concept, the theory of errorless learning, or is it just a casual term?
Okay, so the question is about errorless learning. You're absolutely right that, sorry, the question is, why should we have errorless learning when we actually learn through mistakes? Well, we don't mean to say that in an errorless learning format, people don't make and know they have made mistakes. Rather, when an error is made, the user is guided towards the correct response. This is done a whole lot in other non-computerized autism therapies, done a whole lot in discrete trials learning, where if the client just is not getting the response or is not getting to the response, the therapist will step in and use that trial as an occasion to model the correct response. In this case, to let the student know how it feels to move your finger to the correct target, what the correspondence is between this piece labeled with this letter and this position on the keyboard.
So it fits in other words your idea of the open loop behaviour, that the child can't actually make the corrections, but you can help them to learn or provide the loop.
Yeah, it does rather fit in with the open loop paradigm. You're right. So if a person knows perhaps what the goal is, but can't realize the route to that goal, they're not left frustrated by, oh gosh, I completely failed that trial even though I knew it.
Any more questions?
Okay.
Okay, thanks, Sophie.
Thank you very much.
Okay, so that was the end of the first part of the session, robotics and education. Now we've got a 15 minutes refreshment break before we come back for some more sessions and a workshop as well. Thank you.